Hello. In this lesson, we're going to look at factorizing special binomials. This is the exact opposite or reverse operation of when we were expanding these things. So the difference of two squares and the perfect squares, we have these formulas here, and these are what we used before to expand. So we went from this form where we had the brackets into the simpler algebraic, or the longer algebraic terms, and that was expanding. So this way is to expand. Now we want to do the opposite of expanding, we want to factorize. So we're going to go this way, and we're going to factorize. So we're trying this lesson to go from this to something more like that. And this is really important because we need to be able to go both ways. To be able to factorize lets us then cancel down expressions, especially with fractions, really easily. So for the first one, we need to look at which of these shapes it looks like it's going to be. And I can look at that and see there's two terms, and there's a minus in there, so it's probably going to be something of that shape. Now our first term is a 9, which is a square number, and our second term is 25x squared, which is also squared. So we're in a good place. And if we were to write our a and b here, so our a would be the square root of this number, which is going to be 3, and our b would be the square root of this number, so 5x. So now we can pretty easily go back to this shape. So we're going to write 3 minus 5x, 3 plus 5x. Now we can check this by then expanding again, but I'm just going to leave it like that. So that's how we would first factorize the first one, or a difference of two squares. Now we're going to factorize some perfect squares, or things that are going to become that. When we're doing this, I might change this one to have a minus, it should have. Actually no. There we go. Now we've got an example of each one. So what we're looking at when we're trying to work out is this a difference of two squares, is are the two numbers that are squared, the middle one made up of those square roots multiplied together times 2, and is there a plus or a minus? So our last term here, the only difference between the two is this plus or the minus. Otherwise the two things are exactly the same, and that matches our plus and minus there. So for the first one, we have a plus in front of what would be our last term there. I can see that because I've got a square here and a square here. I'm going to have a hazard a guess that this is going to be one of these type of questions. It's a pretty reasonable one because that's what we're trying to practice. But generally you will have an idea that that's what you're trying to use when you're asked to do this. So for my a, I'm going to find the square root of my first term, which is going to be 2a. For my b, I'm going to find the square root of the second term, which is 4c. Now I can test, does 2ab equal this? So 2ab is going to be 2 times 2a times 4c. We're going to get 2 times 2, which is 4, times 8, which is 16ac. And that's what I wanted. So now I know for sure that I can factorize this, and I'm going to do that. I'm going to go 2a plus 4c. And because this here was a plus, I can add them together. We're going to move to the next one, and it's a similar shape, except this time we have a minus in front of what would be our final term, or our 2ab term. Again, we're going to guess what our a and b will be. So for a, I'm going to find the square root of this one, which is just going to be de. And for my b, I'm going to find the square root of this one, which is 4x. Now again, I can check, what does 2ab equal? 2ab is going to be 2 times de times 4x, which is going to give me 8dex. Alright, I'm going to change this question. This here should, for the sake of this question, this should be an 8, because we're trying to solve these things. So given that this was an 8, we're now able to then factorize this, and remember we've got a negative here, so we're using this form with a negative there. So we're going to get our a, which is de, then minus 4x. and that has to be squared, and I missed the squared there too. All right, hopefully that's made sense to you so far. I'd like you to have a go at questions 1 and 2, and we'll go through them. So start with question 1.